Okay, testing, testing, 1, 2, 3. That should work. I think everything works. Hopefully. Math problem. Cubes. That's it. Alright. Let's start with this. A sub n equals, it's n minus 1 cubed plus n minus 1 3 plus 1. Yeah, that's that. This can be written in a different order. I believe the 3 and n were switched on the board in the math class that I was looking at this in. Yeah, it doesn't matter. Multiplication, yeah, order, whatever. Okay. We start off by saying, alright, we want the nth cube. We want the nth cube, where n can be any number. So like, for example, we could have the third cube. We could have the fourth cube. We could have the seventh cube. It doesn't matter. We want the nth cube, and we want to use the cube before it, n minus 1 cubed, or n minus 1 cubed, like that. We want to use that. So what we're going to do is we're going to say, alright, well, we want to get to 27, because that's the third cube. Right, it goes 1, 8, 27. So we want to get to 27, and what this part of this equation says is take the number before take the cube before 27 in the list of cubes. In the list of cubes, take the one directly before 27. That's 8. Right? Because it's n minus 1 cubed. So we're going to take 8, and we're going to add something. Actually, let me get rid of that 27. Alright, we're going to take 8, simplified, right? We're going to take 8, and we're going to add something to that 8, whatever this is. This stuff doesn't really matter. We're going to add something to 8 to get 27. Alright, and if we're adding something to 8 to get 27, we can rewrite this kind of as 8 plus x equals 27, right? Okay, well, that's simple algebra, right? Subtract the 8 from both sides, x equals 19. Wow, that was really easy, actually. Okay? So now we know that this part, in the case of 8 and 27, this part is 19. Because this part's 8, and this part's whatever you need to add to 8 to get to that cube, that next cube, which in this case is 27. So since this part's the difference, since this part is what you add to 8 to get to 27, that's the difference between 8 and 27. Right? If cuz I just wrote it out actually. 8 plus x equals 27. What is the difference between 27 and 8? It's 19. You subtract the 8 from both sides. Algebra. Right? Okay. So now I know this part is the difference between two cubes. And it's not just any two cubes. It's the difference between two consecutive cubes. How do I know that? Because this is the first cube. This is the cube that I want to get. And this is the cube that I'm using to get there. This cube over here is the cube right before it. So these cubes are consecutive. 27 and 8 are two consecutive cubes. 1 and 8 are consecutive. 8 and 27 are consecutive cubes. 27 and 64 are consecutive cubes. And I know that to get from 8 to 27, I need to add 19. So I know that in that case, if the difference between 8 and 27 is 19, then this part's 19. Oh boy. Then this part's 19. And I know that if I'm trying to get to 64 and I'm taking n minus 1 cubed, I'm taking that 27 and I'm adding whatever I'm trying to get, whatever I want to try to get to 64. And in that case, 27 plus x equals 64. X equals 37. 27 plus 37 is 64, case in point. That was easy. Okay? So, consecutive cubes, difference between two consecutive cubes. Alright? We want to write that. How can we write what's the difference between two consecutive cubes? How can I write what's the difference between 8 and 1? Well, let's say minus 1, but I want to do it for any cube ever. So I want to take n cubed. Writing this stuff is harder than it looks. I want to take n cubed and subtract the cube before it. And the cube before it, as we wrote here as well, is n minus 1 cubed. So I want to take n cubed and subtract n minus 1 cubed. This right here, this is important. This is the difference between two consecutive cubes. What's also the difference between two consecutive cubes? This. This whole thing is also the difference between two consecutive cubes. Okay, so these two things are the same. These two things here. This thing and that thing are the same thing. Okay? So now, how do I simplify this? Because this is not an easy one to do, because I'm cubing a binomial, and that's Pascal's triangle, you know, like the 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, all that crap. So you can go through the whole, process. If you know how to cube it properly with Pascal's triangle, you should come out with n minus 1 cubed should give you n cubed. Oh boy, let me make this neater. Neatness is hard. N cubed minus sorry, I'm thinking for a second here. Okay, minus 3n squared. I'm gonna have to, alright, plus 3n plus, minus 1, because the signs should be alternating, so this is positive, negative, yeah, okay. Okay, so it's n cubed minus that whole thing. Well, I know, right, I know that if I'm taking n cubed and I'm subtracting an n cubed, those two cancel out. So it's n cubed minus n cubed, those two cancel out, and all these other signs are just going to be flipped. So, in the end, n cubed minus n minus 1 cubed becomes, after I flip all these signs and cancel the n cubed out, it just becomes 3n squared plus 3n, minus 3n. I'm flipping that plus, so it becomes minus 3n plus 1. And we want to set that equal to, remember, this whole thing that I just expanded binomially, or whatever, binomial expansion, that whole thing is equal to this part of the formula again. You know, it's the same thing. All these things are the same thing. This time I just expanded n minus 1 cubed. Alright? So n minus 1 times 3 plus 1 is the same thing as 3n squared minus 3n plus 1. And that's the easiest thing in the world to prove. Now we're just factoring. That's literally just factoring. Alright, we'll put parentheses around here, and we'll say, alright, well, that's 3n. Right? We can factor out of 3n from 3n squared minus 3n, and it'll be 3n times n minus 1, which is the same thing as writing, I'll write it in the same order I did earlier. It's the same thing as writing n times n minus 1 times 3. And then we're just adding that 1 that we have over there. So, there we have it. We're using 1 cube to get to the next. Yeah, that's it. We're done. Bye-bye.